Here we have example classes is to calculate a rectangle shape. So for this rectangle shape, we have two initialized value, right? The W and H. The W means the width and H means the height, right? So if you want to calculate the area of a rectangle, you just call this internal function a rectangle dot or self dot area. And here we have a decorator. It's called property. The decorator concept is, I think, is question in the lab 2, right? If you came into the lab 2, there will be some question related to the decorators. And here the decorator is, it means for this class, rectangle, we have a property which calls the parameter. In the home assignment, our decorator maybe have some function like decorate some new features to the original function. So your input is a function and your output is, for example, like if your input is a sum of two values, for example, 1 plus 2, right? Or 2 plus 2. And your decorator is the square of the input function. So your total output will be, let's say, 2 plus 2 and then square. So your output is 16. So that's a decorator we asked in our home assignment. But here is we have a property of a rectangle is parameter. It also calculates the parameter of a rectangle. And you can call this if you want to get the parameter of this object. So here we create a new object. The rectangle is with width 3 and height is 4. So whenever we define such an object, we actually assign this two values 3 and 4 into the initialized parameters here. So the self.w equals 3 and self.h equals 4. This is a class called versioned rectangle. It means the professor given a version of this class, and here the version is 1.0. So you can call the version of this rectangle by call its properties here. Well, you can also add a attributes to this class. Let's say here we have whether this rectangle have a border. So you add a new feature or attributes to this object. The border is true. And then you call the object property border. The return is true. I don't know, the traceback maybe it's trying to trace back the previous version of this object, and it probably just shows up the previous version of this object has no attribute border, right? Did you get this point? Sort of. Okay, I mean, let's say the version 1.0 and 1.1, right? For the 1.1, even if we didn't assign the version to it, but we add a new property called border, and the professor used a package called traceback, and it traces back the object back to its previous version. So the previous version has no dot border attributes, right? So here is the professor defining a new function. It means the unit fabric cost for example, like if you wanted to building a house, let's say even if we have an area, we should consider the cost we need to spend on building this house. So he defined a internal method called cost with a price ratio unit per fabric cost. Multiply this area. So we create a new object called fabric rectangle with the 4 and 5 as the input, and we define a new cost is 12, let's say $12 per area. So it means, I think it means 12 multiply 4 multiply 5, right? So it's 240. Oh, you can also call the method from external. So you just assign a class to this internal method. The first argument is the object, and the second one is 12. It's the price. We can just change it into, let's say, 5. So it's 100. It's a new value. I think that means we can, if we define a class, even if we didn't initialize an object, we can also call the internal method by calling this class. So this is the properties we talked about at first. Is the parameter. The parameter of this rectangle is 14. Means 2 times. Is it? It's the previous object called R. This R is the rectangle is 3 and 4, so its parameter is 2 multiply 3 plus 4 is 14. So here we have the method called static method. Sometimes the method does not depend from the object itself. This is its implementation does not mention self. In that case, you can make it into a static method. For instance, we can define a class up and down of string method like this. If we use the static method, so this method is, I think it's a, I don't know, maybe independent function, and similar to the previous one, we can call this class by using the static method. It's a function inside of this class. So we we calculate the uppercase of these input strings. Let's say a lowercase cat, and the return is the uppercase. So directory is listing the internal all objects, all attributes of a class. So for example, like we have a given object R. So let's see what it has, right? So you remember we defined some in a method and properties, right? Here, right? We have W, area, and parameter. But if we call this directory, our output should be well, we have a lot, right? So this underlined properties means, I think it means is hidden properties, right? It's something you cannot see, but it's like default properties. For each class, you should have such properties. We're gonna go through some of this in the following discussion. But you can see here we have area, we have WH, border, parameters that we defined in the previous class. So there's a function called get attributes. So here, if we're given two attributes named as W width and the parameters. So for each for each attribute in this list, we can use this function to call its internal values. So we assign this value to a temporal variable a, and then we print it out. So the W is, so you print out the S, which is the string here, and then you can get the values of each. The width is 3 and parameter is 14. And yeah, this is the same method we get the area. Yeah, this is kind of the same. Yeah, you can also add some attributes to this object. The previous one we used is r.color, but we can also use the set attributes. But rather than the previous one, we have the get attribute. This one is we can set a new attributes. We can also have some subclasses, which means this is a class underneath a class, right? So here we have fabric rectangle, and this I remember I think it's the parent class is from the rectangle. So here the fabric rectangle is a subclass of rectangle, which means it inherits some of the, well, all of the attributes from the rectangle. And we have some specific defined attributes to these fabric rectangles. So I think in this way you can make your codes more efficient, right? So here we test the cost, which is defined in this fabric rectangle, and we can also call the parameters defined in this parent class, which is defined in a rectangle, right? So it's 4 multiply 5 and multiply 12, which is 240, and the parameter is 4 plus 5 times 2 is 18. You can also check whether this object or variable is a object. You can use this function called isInstance. Yeah, so the return is a Boolean value, true or false. Sorry. Here is we have a object called fr, and we have a class called fabric rectangle. So our judgment is whether this object belongs to this class, right? So if it's true, that means it is defined by this fabric rectangle class. So since it's inherited from the parent class rectangle, we can also test whether it belongs to the rectangle class. So the return is also true. And you can also define to get the object class name by using its hidden attributes like the class and the name. So your return will be the fabric rectangle. And here we have some ideas related to our, I think it's the lab 1, because we have arithmetic operations like add, subtract, and multiplication, and yeah, which is defined in a complex number class, right? And also we have some comparison operator we can find out here. So by giving a complex number, we have the real parts and the imaginary parts. We have the add, sub, multiplication, and I don't know, modulus, square, modulus, inverse, true division, representation, equal, right? Do you remember this EQ? Yeah, we also have some, let's say LT, less than, right? This type of comparison operator means if we have not just, let's say, by adding these numbers, right? If you're trying to sorting these numbers, we have a way of, you can define your own way to sorting these numbers, right? Even if it's hidden, it's a hidden class, it's a hidden attribute. You can define your own way to sort these numbers. For example, like this way, we can sort by the real numbers. You can also sort by the imaginary numbers, right? You can just create your own way to compare these numbers. So if you're finished lab 1, so this operation will be quite easy for you. So if you compare this to complex number, you're using the equal operator. You actually just call this function a method here, right? Whether it's equal to the other one, right? So here is the equality and sorting is the idea I mentioned earlier. If I want to compare to complex numbers, you can return whether I think it's an AND logic expression. That means real part is less than the other real parts, and the imaginary part is less than the other one. So what you assign here, you define a function, you define a method or function here, and you assign this function to the hidden less than attributes. This is the meaning of this line, right? So after this, you can compare this to complex numbers, whether the C1 is less than the C2. So the return is true. If we, we cannot use this larger than because we haven't defined how to compare which one is larger, right? Oh, it is returned. I don't know, maybe it's defined in some underneath hidden method. So if we given a list of a complex number, you can using this function to sort these numbers. So last one is implementing dictionary-like objects. The bracket method used to assign value to a dictionary element, as in D3 equals cat is implemented while the set item method and the bracket method used to get values from dictionaries, as in D3, is implemented while the get item method. So if you want to create objects that behave like dictionaries, just implement their set item and get item method. You can also implement the length to return the length of the object. So you can create a yeah, I think the things here is you can create any object, any class by giving a method behaves like a dictionary, right? You can return the object with a index. Let's say the index 3 is the cat. The index 2 is what? Do you get this point? Yeah. Yeah, let's see what's the example given here. So the professor given a class called the time-stepped dictionary. I think it's called something like if you're given you are create a new object and you're given a time step, the time that you created this object, right? So the set item here is the decay is V, and the time step K is the time. Do you know this time? Okay, this is so as you see here, we have import time package, right? So the time is the return is the current absolute time by nanoseconds. So it's like a tick-tock, right? So it's not like 1 second and 2 seconds, but in absolute numbers. Like the UTC time, but in nanoseconds. So that each time step is different. You can calculate the deviation from this step to the second step. For example, like in between of this is your function, right? If you have a loop, like a for loop, while loop, or whatever you want to measure, you can insert a first time step as a maybe T1, and the other one is maybe T2. We call the same function here time, right? And then you can calculate the deviation between T2 and T1, right? And then we, I remember it's multiply 1,000 or something. You just change the nanosecond into millisecond. You can measure how much time you spend on this snippets of code, right? So that is time. So here it gives a specific parameter to this object with absolute time step, which is different by each object, right? Shouldn't be the same. So here is we have a class called time step dictionary, right? And time step dictionary cat is equals to 4, and the bird equals to 5. So here, after we assign these values, we already have a time stamp here, right? Just imagine we have a T1, and then you sleep for 0.5 seconds. Just wait for, that means hold on for 0.5 seconds, and then you measure it again, and then you sleep another 1 second. So let's just see. Yeah, here we have an age. How do you return the age? Is the current time step minus the time that it created, right? This is the, as I said, maybe this is the T1. This line is the T1. This line is the T2, and T2 minus T1 is the deviation or delta time, right? We that means the age of the objects, right? So let's see what's the time we have. So the cat is 1.5, and the bird is 1.0 almost. And why do they have 0.5 deviation? Because here we have 0.5 waiting time, right? So I think we almost finished this class review. Thank you.